Yes, myself, Dr. Shreya, and I'll be taking your online classes for chemistry, bio, mathematics for class 9th and 10th ICSE students. See, I'll just give you a brief introduction about myself. I have done my homeopathy and I have been into teaching field for the past almost now 18 years. I have been coaching students for competitive exams for maths as well as for science. So you all might be knowing exams like Mathematics Olympiad, Prabhutva, Pravinya, Pradnya, Science Olympiads, Homi Baba. All these I am giving coaching for in my classes, and as well I am conducting classes for students of 9th and 10th grade for ICSE for maths and science. So I'll be starting today with the king of chemicals, chemistry class 10 ICSE students, sulfuric acid. The most important part of sulfuric acid is its preparation on a large scale. Okay, so today we will be discussing in length how is sulfuric acid prepared in prepared on a very large scale. So that process, the name of that process is known as contact process. Contact process. So we are going to understand. You will be seeing a preparation which is on the board right now here, and I have shown you some structures over here. We will be discussing in detail about this. The first that you see, sulfuric acid, if we want to prepare, what do we all need? We need first, the most important element is sulfur. Okay, so how do we obtain that sulfur? We either take that sulfur which is in the purest form, or we can also prepare sulfuric acid with the help of a pyrite burner. A pyrite burner where we make use of iron pyrite, that is iron disulfide, and we blow a lot of air into this burner. So in this burner, if we see that iron pyrite is getting burnt and we get what is known as ferric oxide along with evolution of sulfur dioxide gas. Okay, so purposely I have not done the balancing over here. I find that most of my students, when I take offline classes and I see the errors that they make, they are able to frame a reaction, but balancing them, and balancing not the easier one, but balancing certain little difficult ones, they find it challenging task. So for those who are having difficulty in balancing, I'll just help you how to start with and what to look for. Okay, so if you all can see, Fe here is 1, but Fe here is 2. Also, if you notice, oxygen here is 2, that is even. And what we find here, oxygen is even, but here oxygen 3, it is odd. So the most important challenge and the most important, hack in balancing is whatever odd is there, first try to make that even. Try to make that even. So here, because oxygen is 3, I am making it even by adding 2 over here. Can you all see this? So here my oxygen has become 2 3s are 6 and this 2, that is 8. Correct? Are you getting this? So now if you see in that process, my iron has become 4. So I add here 4. Now in this process, you see sulfur has become 8. So now in order to make this sulfur 8, I will add 8. Now the last thing is my oxygen. Oxygen here is 2 3s are 6 and 8 2s are 16. So 16 plus 6, that makes it 22. So how do I make oxygen 22? It's very simple, because here there is 2 and we multiply 2 with 11 in order to get it 22. So this is how we do the balancing of some difficult, some challenging reactions. So the most important task in contact process is obtaining sulfur dioxide. Either you obtain sulfur dioxide from iron pyrites, or you can as well take pure elemental sulfur, which is called Louisiana sulfur. Louisiana sulfur. This is the purest form of sulfur that you can get. You burn it in the burner and you get sulfur dioxide. But you should understand this thing, kids, that when we are doing this in the burner, a lot of impurities are already there in the air that we are blowing in. Air contains a lot of other gases besides oxygen, which is our primary element. So we need to, हमें उसको क्या करना पड़ेगा? We will need to purify it. We will need to purify that sulfur dioxide that is coming out from this burner, because if we don't purify it, we will be finding difficulty when we will be wanting to obtain sulfuric acid from it, because that process of obtaining sulfuric acid from sulfur dioxide requires the use of a catalyst. You know a catalyst, right? Catalyst is something which will enhance, or at times negative catalyst will decrease the rate of a reaction, and that in a large scale preparation kits, it's going to be very, very, very expensive task for us. So we need to make sure that whatever we are putting in the contact here in this tower should be absolutely pure, should be as much pure as it can be. So we are going to now put that sulfur dioxide that we obtain here through these reactions, we are going to put it into a dusting chamber. These are all purification units that you all can see. Till here, we have purification units, where the first that you all see is the dusting chamber, where the dust from the air, the pyrites के dust होते हैं, थोड़े other gases होते हैं जो हमें नहीं चाहिए. So all these dust, they are being, in this chamber. This is an electronic chamber. So इसमें what happens, the dust will settle down and the gas will flow into another purification unit, which is called a scrubber. Okay, this scrubber is going to make the dust particles, the other gases which are unwanted, heavy. Okay, and here this is done by blowing in a lot of water. So all these dust particles, all these heavier gases, everything that is unwanted will settle down over here, and this can be removed from this outlet. But now the things that are going here are going to be moist, right? Because we have blown water from here in order to scrub the dust particles. So this gas that we want, sulfur dioxide, is going to be moist, and we cannot take a moist gas, right? So we need to pass it through another tower, which is known as a drying tower. So in this drying tower, we are making use of a drying agent, which is of course concentrated sulfuric acid. So we dry our gas with concentrated sulfuric acid, which we all know is a very good drying as well as dehydrating agent. Okay, so here a short thing that I'll clarify for those who are having this, those who want to know the difference between a drying agent and a dehydrating agent. So drying agent is something like it will just absorb the moisture. It will dry the things, like just like when you all take a bath and you come out, you just wipe your body, right? You just dry your body with a towel. So that is the work how the drying agent does with the chemicals which are wet. They just make it dry. But a dehydrating agent does a work which is removing the water chemically combined with that element or with that compound. So like say if you go in a very hot sun, okay, and then you find a lot of sweat from your body coming out. So that's exactly the work of a dehydrating agent. Dehydrating agent just acts like that with the compound. It removes chemically combined water molecules from that compound. So here we are making use of concentrated sulfuric acid as a drying agent, to just make our compound, our gas sulfur dioxide, dry. After all this has been done, that is, after our gas is passed through the dusting chamber, through the scrubber, then the drying tower, we still are not very sure, because in the burners there are a lot of impurities which are related with arsenious oxide impurities. So we then pass it through another purifier where we have already, kept ferric hydroxide. Like, we know that certain compounds, they have affinity to combine with certain elements of other compounds. So does ferric hydroxide. Ferric hydroxide is known to react or to absorb arsenious oxide into it, just like how potassium hydroxide absorbs carbon dioxide, how alkaline pyrogalol, it absorbs oxygen. So does ferric hydroxide can absorb the impurities of arsenic, that is arsenious oxide. Okay, I hope you are getting what I'm trying to say. So in all these chambers, dusting chamber, scrubber, then of course the drying tower, and then the arsenic purifier, we are subjecting our sulfur dioxide through all these purification unit, and then we are making sure that we pass it into, this is called a testing box. This is called a testing box. कि we need to make sure कि हमने जो किया है वो सही भी है या गलत है. तो मतलब सारा हमारा गैस ऑलमोस्ट प्योरीफाई हो भी गया है या नहीं हुआ है, तो उसके लिए हमने इसको इसमें टेस्टिंग बॉक्स में डाला है, जहां पर हमने एक छोटू सा, एक वेरी स्मॉल होल वी हैव क्रिएटेड बच्चे लोग. सो व्हेन आवर गैस इज पासिंग थ्रू दिस होल, एंड इफ वी आर एबल टू सी दिस लाइट थ्रू एंड थ्रू विदाउट एनी, व्हेन यू सी कि एक सन रे आती है आपके विंडो से, तो आपको अगर उसमें डस्ट पार्टिकल्स होते हैं तो वो दिखता है. दैट्स वी से इन केमिस्ट्री टिंडाल इफेक्ट. तो अगर आप इधर देखोगे तो आपको वो डस्ट पार्टिकल्स अगर नजर आए तो देन यू हैव टू सब्जेक्ट इट बैक इनटू दिस प्रोसेस. बट इफ यू आर श्योर कि नहीं, वी आर नॉट एबल टू सी द टिंडाल इफेक्ट एंड वी आर गोइंग टू सी जस्ट अ रे विच इज कमिंग, तो देन योर गैस इज रेडी टू गो इनटू दिस second very important tower, contact tower. This is called a contact tower. This sulfur dioxide now moves into a contact tower. Can you see these vertical pipes? If you can see these vertical pipes, and you see this, what I have done, this is a catalyst, and this catalyst is already heated to around 400 to 450 degrees Celsius. This catalyst is vanadium pentoxide. Vanadium pentaoxide. Now, this catalyst we have, purposely made these vertical pipes, because these vertical pipes से क्या होगा, जो catalyst है उसको ज्यादा surface area मिलेगा, और ज्यादा surface area बोला तो अच्छे से the sulfur dioxide gas, because it is gas, it will be large surface area, large exposure, so better absorption. And then in this contact tower, the reaction that is taking place at 400 to 450 degrees Celsius along with the catalyst, you can see how this sulfur dioxide reacts with oxygen. And because this is a contact, here we are all this, the same thing is going, and everywhere बच्चे लोग sulfur dioxide is going with excessive air. Now, why excessive air, I will tell you a little later when we go into this process during the reaction. Okay, so here in the contact tower, you can see the formation of, from the sulfur dioxide, sulfur dioxide reacts with oxygen to form sulfur trioxide, and this reaction is highly exothermic. And here we are using a catalyst, vanadium pentaoxide, temperature of around 450 degrees Celsius. Again, the balancing part I have left for you all to, to do with you all. So let's start with, again, here we see oxygen even, oxygen even, oxygen odd. So what did I tell you? Make the odd, turn the odds into even, turn the odds into even. So now we are going to first make use of that fact and turning the oxygen, 3 2s are 6. So now our oxygen has become even and it has become 6. And meanwhile, the sulfur has become 2. So let's make sulfur 2 and then count our oxygen. So can you all see 2 2s are 4 and plus 2 6. So oxygen is balanced. Sulfur 2, sulfur 2, sulfur is also balanced. So this is how you should do balancing. So now we see in this contact tower, the reactions that are happening is this. Okay, this is a reversible reaction. After this, the sulfur trioxide that is being formed is then passed into another tower, and the name of this tower is, this is called absorption tower. This is called absorption tower. This tower is subjected to a pressure of around 1 to 2 atmosphere. 1 to 2 atmosphere. Now in this tower, we are sending what we have formed, sulfur trioxide. And in order to prepare sulfuric acid, बच्चे लोग, we are making use of concentrated sulfuric acid. And now, like how I was puzzled during my time, I know many of you might be thinking कि मैम सल्फ्यूरिक एसिड बना रहे हैं और सल्फ्यूरिक एसिड ही यूज कर रहे हैं, तो इसका क्या पॉइंट है? So you know, at certain times, in order to prepare things in large quantity, like if I want to, you know, double up my things, so we keep our money in the bank, right? और क्यों रखते हैं बैंक में? ताकि वो मनी हमको डबल करके या 7%, 8%, whatever interest, the money will grow. ओके, तो हमको मनी बनाने के लिए मनी का यूज करना पड़ता है, करेक्ट बच्चे लोग? सो द सेम वे सल्फ्यूरिक एसिड बनाने के लिए भी हमें सल्फ्यूरिक एसिड का यूज करना पड़ता है. बट यहां पर हम जितना सल्फ्यूरिक एसिड यूज कर रहे हैं ना, I am going to show you with evidence that we are getting double the amount of sulfuric acid that we are preparing. Okay, so shortly I will show you during the reaction process कि कैसे जो हमने यूज किया उसका डबल कैसे हमें मिलता है. तो और why we, so this sulfur trioxide from the contact tower that we have prepared is now going into another tower which is subjected to 1 to 2 atmospheric pressure, and in this we are going to prepare with the help of sulfur trioxide and concentrated sulfuric acid. Now I am showing you what we have done here कि ये सल्फर ट्राइऑक्साइड कहां से आया है? इधर से, कॉन्टैक्ट टावर से, करेक्ट? और फिर हमने ऊपर से क्या डाला है? सल्फ्यूरिक एसिड, कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड. नाउ यू सी व्हाट वी हैव प्रिपेयर्ड. H2, S कितने हैं? 2, ऑक्सीजन 3, ऑक्सीजन 4, तो ऑक्सीजन कितने हो गए? 7. So it is H2S2O7. This product is known as oleum or pyrosulfuric acid. What it is known as? Oleum or pyrosulfuric acid. Okay, so reaction in dilution tank. Now we will be saying कि in the dilution tank, now here this is a dilution tank. So whatever oleum that is being formed over here will go into this tank. In this tank we have water. So whatever oleum goes here, and the reaction that takes place in the dilution tank is the oleum and water. Now can you all see what we have got? Concentrated sulfuric acid. Now if I balance it, H2 is how many? H2 is how many? 2 and 2, 4. So I put here 2. So I got 4. Now S is how many? 2. S is how many? 2. Oxygen 7 plus 1, 8. 2 4s are 8. So now have you realized बच्चे लोग what I was telling you कि हमने जितना भी सल्फ्यूरिक एसिड यूज किया, we obtained double the amount of sulfuric acid that we had already used. तो हमने हमारा तो रिकवर किया ही, और हमने एक्स्ट्रा And when we are all doing this on a very large scale, it makes a great sense to use the same thing in order to prepare the same thing. Okay, 3-4 very important things that you all have to understand while writing the board exams. There are certain questions which are involved. Ki write the reaction in the pyrite burner. Of course, when we write a reaction, you all have to understand we have to just not write the reaction, we have to write a balanced chemical reaction. Many times the students in hurry, they write the reaction and somehow they either don't balance it or hurry so much, or they get entangled in the balancing that they balance it very fast. So if you know the right way of balancing, this won't be a hassle during the exam. So most important, what is the reaction occurring in pyrite burner? So you can either go with this or you go with this. But if they mention कि you want a pyrite burner only, so then you have to mention the first reaction, not the second. Okay. Then what is the reaction that is taking place in the contact tower? So in the contact tower, बच्चे लोग, we are using a very a temperature which is called optimum temperature. Now, why this temperature and why not a temperature higher than this, or why not a temperature lower than this? So, very important, many a times they ask you what are the conditions that are necessary during the formation of sulfuric acid. Okay, so the conditions, and then sometimes they ask, please explain with suitable reason why we are using this temperature. So the conditions that are necessary are, of course, a catalyst, vanadium pentoxide. So now first we will talk about the catalyst. Here, the more efficient catalyst is not vanadium pentoxide. It is platinum. It is platinum. But there are certain, drawbacks that, or we can say our limitations of not using platinum. Platinum, as we all know, is very, very costly metal, correct? And secondly, platinum gets very, very easily poisoned by impurities. So, although we have made sure to pass our gases through all these purification units, but always the chance is there that some impurities might skip. So, platinum is the one which gets easily poisoned. So, we are not making use of platinum. So, vanadium pentoxide is then preferred over platinum, mainly because it is less easily poisoned. It is, and of course, it is cheaper than platinum. Now coming to कि ma'am, why only this temperature? So बच्चे लोग, ये टेम्परेचर तो हमारे बुक में बाद में लिख कर आया, पर इसके पहले जिन लोगों ने ये बनाया, दिस पीपल हैव मेड यूज ऑफ temperatures like 300, 350, 400, 500, 550, 600, and then they realized it कि जो 400 से 450 का रेंज का टेम्परेचर था, उसमें सबसे ज्यादा यील्ड मिल रहा था सल्फर ट्राइऑक्साइड का. एंड नॉट ओनली दैट, इफ यू सी दिस रिएक्शन, यू कैन सी दिस रिवर्सिबिलिटी साइन, करेक्ट? रिवर्सिबिलिटी की साइन भी देख रहे हो तो आपको, और प्लस यहाँ पर आपको ये ट्राइंगल, मतलब दिस इज एन एक्सोथर्मिक रिएक्शन. तो अगर आप सोचो, अगर आप कुछ ज्यादा ही हीट दे देते हो, ठीक है, तो ये रिएक्शन में ऑलरेडी हीट बाहर आ रहा है, ऑलरेडी इट इज evolving a lot of heat. So what is the key word that we use during the exams, writing the board's paper, why this temperature? Because this is, first of all, the reaction that is taking place in contact tower is an exothermic process. Okay, so exothermic reactions are always favored at low temperatures. Okay, but we cannot go very low, because if we go very low, then the yield is not as good as what we get during this. So the best temperature where we get maximum yield also and less wastage of fuel also is 450 degree Celsius. So exothermic reactions, they are favored at very low temperature. And then also we told you that we are subjecting it to a pressure of around 1 to 2 atmospheric pressure, क्योंकि हमको चाहिए कि ये एब्जॉर्प्शन टावर में जब सल्फर ट्राइऑक्साइड और सल्फ्यूरिक एसिड मिले, तो वो मिलने के लिए भी उनको एक प्रेशर देना पड़ता है, तभी जाकर ये लोग मिलते हैं. पर हम बहुत ज्यादा प्रेशर भी नहीं डाल सकते हैं, क्योंकि ये टावर कैसा है, इसमें एसिड बन रहा है, तो एसिड रेजिस्टेंट टावर है, तो एसिड रेजिस्टेंट टावर बनाते हैं, पर अगर बहुत ज्यादा प्रेशर डाल दिया ना तो हो सकता है ये टावर में कुछ लीकेज हो सकता है या कुछ देयर कैन बी डैमेज. सो वी हैव टू मेक श्योर कि प्रेशर भी बने. प्रेशर इसलिए भी बनाए रखना पड़ता है बच्चे लोग कि आप अगर इधर देखो ना तो ये वॉल्यूम देखो, ये 2 है और ऑक्सीजन कुछ नहीं मतलब 1 है ना. तो यहाँ पर टोटल वॉल्यूम अगर आप देखो तो 2 पार्ट्स ऑफ सल्फर डाइऑक्साइड है, 1 पार्ट ऑफ ऑक्सीजन है, जबकि इधर हमें मिल रहा है सिर्फ 2 वॉल्यूम्स ऑफ सल्फर डाइऑक्साइड. तो इधर हमारा वॉल्यूम ज्यादा है और इधर हमारा वॉल्यूम कम है. So in this case where we have our volume in the reactant side more and in the product side we have our volume very less, तो उस टाइम पे हमें उस रिएक्शन में हमें सल्फर ट्राइऑक्साइड को भेजना है. अगर वापस से सल्फर ट्राइऑक्साइड इसमें बदल जाएगा तो अपना पूरा मेहनत वेस्ट हो जाएगा. सो वी नीड टू सब्जेक्ट दिस टू अ प्रेशर, वी नीड टू सब्जेक्ट दिस टू अ pressure. So the pressure is being maintained at around 1 to 2 atmosphere. Okay, so this is how it goes. So this reaction is very important. H2H2O7, this is called oleum or pyrosulfuric acid. This is called H2SO4. Now there is one more very important thing that before I finish this video about contact process, the most important part that is remaining is कि मैम आपने हमें बता तो दिया कि यहाँ पर 2 वॉल्यूम मिलते हैं, ज्यादा मिलते हैं, बट सल्फर ट्राइऑक्साइड को हमने तो 9th में पढ़ा था कि सल्फर ट्राइऑक्साइड को पानी में भी डाल दिया तो भी सल्फ्यूरिक एसिड मिलता है. तो हम ये प्रोसेस क्यों नहीं यूज करते? हमने ऑलरेडी सल्फर ट्राइऑक्साइड बना दिया है, तो इसको एब्जॉर्प्शन टावर में डालकर ओलियम बनाकर फिर पानी में डालना, ये कहाँ की क्लेवरनेस है आपकी. तो फिर यहाँ पर एक चीज है बच्चे लोग कि जो भी चीजें जैसी भी होती है सबका कोई ना कोई वजह होता है, कोई ना कोई रीजन होता है. द मोस्ट इंपॉर्टेंट, यस वी हैव लर्नड इन द 9th grade chemical changes and reaction chapter में कि in order to prepare sulfuric acid we make use of sulfur trioxide, in order to prepare sulfurous acid we make use of sulfur dioxide. बट यहाँ पर एक चीज जो हमें तब नहीं समझाई थी, अब हमें वो बताया गया है कि जब भी हम सल्फर ट्राइऑक्साइड को पानी में डिसॉल्व करने का देखते हैं तो जितना भी हमारा सल्फर ट्राइऑक्साइड बना है पूरा का पूरा सेटिस्फैक्टरीली डिसॉल्व होता नहीं है, और जो हो भी जाता है ना तो वो मिस्टी ड्रॉपलेट्स बनाता है और उसको फिर कंडेंस करना हमारे लिए मुश्किल हो जाता है. तो 2-3 चीजें इसमें साफ है कि सल्फर ट्राइऑक्साइड इतनी मेहनत से जो हमने बनाया वो पूरा मतलब सल्फ्यूरिक एसिड बनने में पूरा यूज नहीं हो पा रहा. इट इज नॉट गेटिंग सेटिस्फैक्टरीली डिसॉल्व्ड इन वाटर, forming misty droplets, and at the same time those are very difficult to get condensed. So हमको ये वाला जो प्रोसेस है सल्फर ट्राइऑक्साइड डिसॉल्विंग इन वाटर करके सल्फ्यूरिक एसिड बनाना, ये we are not able to do this. Are you getting this बच्चे लोग? So the most feasible way, the most doable way is the way in which we are dissolving sulfur trioxide in concentrated sulfuric acid forming oleum, and then in the dilution tank we are diluting our oleum into sulfuric acid. Okay, so I hope you all have understood the reactions that are occurring in different chambers, why our sulfur dioxide, and yes of course I told you I will be saying why we need air throughout, बिकॉज एयर के अंदर जो ऑक्सीजन है ना वो हमें चाहिए, और आपको पता ही है एयर के अंदर ऑक्सीजन है ही अराउंड 20-21%, 20 to 21%. सो वी हैव टू मेक यूज ऑफ एक्सेस ऑफ एयर सो दैट इन ऑल द चेम्बर्स, इफ यू सी हियर वी नीडेड ऑक्सीजन. तो ऑक्सीजन आपको हर जगह लग रहा है, तो इसके लिए आप थोड़ा ऑक्सीजन एक्सेस में लेते, मतलब हवा ही एक्सेस में लेते हो ताकि ऑक्सीजन ज्यादा मिल सके. So this is, I'm going to share some charts with you. I'm going to share some questions also with you, And if you all want a video regarding solving of those questions that I'm sending you, or you need any help, I'll be sharing my contact number. Please feel free to contact me or message me in the comment section. Please explain me this, ma'am. So I'll be providing you the explanation, the answers for all those questions. Meanwhile, please go through this, and I hope you find this video helpful. If you find it helpful, kindly subscribe to my channel. Thank you.